So welcome back, Stella. As I said, in this video, we are going to do this integral and this integral, and we shall prove that this is equals to this and this is equals to this. So basically, in this exercise, what we are going to do is that, let me go to this. Let me create some new papers. This is 61, 62, 63, 64. Okay. Wait a minute. Okay, let's go back to our stuff. Let me go on the next page. That's exercise. How much? Let's see. It's part 1, question 5. So in this exercise, we have to find this integral, and we will have to prove that it is equals to what? So we have to find integral of sec theta d theta. We are going to show that it is equals to this and this. Okay, now how are you going to do this question 5? So here, using the appropriate substitution, using an appropriate substitution, we are going to find the integral of sec theta d theta, prove that it is equals to, we're going to find the integral of sec theta d theta, prove that is equals to sec theta, ln of the absolute value of sec theta plus tan theta, which is still equals to ln of what? The absolute value of tan, let me see, which is still being equals to what? You should remember this result, which is still equals to the ln of the absolute value of tan x on 2 plus pi on 4. Remember these results. It's true they are, some are in your formula booklet, but remember them. It's very important. Ln of the absolute value of tan x on 2 plus pi on 4. Okay, so we need to, so the first thing, if you are given such an exercise, the first thing, oh, I forgot something, plus constant of integration, which is equals to ln of the absolute value of tan x on 2 plus pi on 4 plus our constant of integration. The first thing you are supposed to do in this exercise is to, first of all, prove that, because it's very easy to prove that integral of sec theta is equals to this. You first prove this. Now, to prove that this integral is equals to this, what you will need to prove is that you will just need to prove that sec theta plus tan theta is equals to what? Tan x on 2 plus pi on 4. If you are capable, so the first part of this integral will be to prove that integral of sec theta is d theta is equals to what? Ln of the absolute value of sec theta plus tan theta plus a constant t. The next part will be to prove that sec theta plus tan theta is equals to what? Tan x on 2 plus pi on 4. If I'm capable of proving that this is equals to this, then necessarily this answer will be equals to this answer. I hope we are clear. So the next part of the first part of the integral, we are to prove this. So let's find the integral of sec theta d theta. We know that the integral of sec theta d theta is the same thing as what? Integral sec theta is the same as 1 on what? Cos theta d theta. Now, you see that this is already in the form, integral of what? 1 all over a plus b sine what? N theta nx plus c cos what? Nx. This integral is in this form. You understand? So whenever we said in the lectures that whenever we have an integral of this form, what are we supposed to do? We let our t to be equals to what? Tan of this angle divided by what? 2. Tan of nx divided by 2. Remember that. Okay, so we are here. So we are going to let we're going to let what? T to be equals to what? Tan of this angle. This is our nx here is what? 1 times theta. So we are going to let T to be equals to what? Tan of 1 times theta, which is theta. Pardon, wait, let me write this. So we are going to let our T to be tan of what? Nx. Nx divided by 2. Our nx is what? Theta. Theta divided by 2. So theta divided by 2. Very good. From there, we are going to find what? We are going to find d theta, because in the integral there is d theta. So this implies when I differentiate this, I will differentiate this implicitly. When I differentiate this, I'll have what? 1. And I multiply by what? D theta. So dt, since I'm differentiating with respect to t. So dt will be equals to what? Dt will be equals to, when I differentiate this will simply be equals to what? I differentiate what is inside. Theta on 2 prime times what? When I differentiate tan, why behaving as this? Why behaving in a way that this theta on 2 is the same as u? This will give 1 plus what? Tan square u. But our u is what? Theta on 2. Is that okay? Since I was differentiating with respect to theta, I write here d theta. So this will be equals to, when I differentiate this, because this is theta on 2 prime, don't forget there's a prime here. When I differentiate this, I will have a half into 1 plus tan square theta on 2 into what? D theta. So I'll make d theta the subject. It implies d theta will be equals to what? 2 dt on what? 1 plus tan square theta on 2. But remember, our t was equals to what? Tan theta on 2. So this implies our d theta must be equals to what? 2 dt on what? 1 plus t squared. We have already our d theta. Now, what do we have to find? We have to find cos theta. We have to find cos theta because we have to substitute it here. So I'll draw my right angle triangle. This is A, B, and C. What is the angle we put here? The angle we put here is the angle of what? Tan. Is the angle of tan, not the angle. We don't take that angle from here. We take it from what is inside tan. What is inside tan is what? Theta on 2. So this angle is what? Theta on 2. Don't forget that our t is equals to tan. Let me write this. Don't forget that our tan theta on 2 is equals to what? T, which is t on 1, which is opposite all over y, adjacent. Very good. Now, if this is our angle theta on 2, the side opposite to this angle is what? This side. So this t will be here, and here will naturally be equals to 1. So this is the hypotenuse, square root of 1 plus t squared, according to Pythagoras theorem. Very good. Now we are to find what? Cos theta, because we will have to substitute here. Substitute it here. Remember from trigonometric transformations that cos n theta is equals to what? It's either equals to cos square n theta on 2 minus sine square n theta on 2. It can still be equals to 2 cos square n theta on 2 minus 1, or it is still equals to 1 minus 2 sine square n theta on 2. Okay, we are to find cos theta because it is cos theta which is in our formula. But be very careful, in our triangle there is no theta, there is instead theta on 2. So cos theta, we shall first write it using, let's use this one. We shall first say that it is equals to what? 2 cos square what? Cos n theta is equals to 2 cos square n theta on 2. So this is theta. This will be theta on 2 minus 1. Now, from triangle ABC, we see that cos theta on 2 is equals to what? It's adjacent over hypotenuse, which is 1 all over what? The square root of 1 plus t squared. Is that okay? So this implies our cos theta will be equals to 2 into what? This 1 all over square root of 1 plus t squared, all that square here, minus 1. So this implies our cos theta will be equals to what? This I will have 2 here all over 1 plus t squared minus 1. So this will be equals to 2 minus 1 plus t squared all over 1 plus t squared. So this implies cos theta will be equals to what? 1 minus t squared all over what? 1 plus t squared. So that's our cos theta. Having find our cos theta and d theta, we can then go and substitute it inside here. So, so it implies the integral of 1 all over cos theta d theta, which is sec theta, will be equals to, I'll substitute my d theta. What's d theta? D theta is equals to, let me go back. D theta is simply equals to what? 2 dt all over 1 plus t squared. So 2 dt all over 1 plus t squared all over cos theta, which is 1 minus t squared all over what? 1 plus t squared. Is that okay? So this will be equals to what? This will be equals to the integral of 2 dt all over 1 plus t squared times what? Times this is 1. Wait a minute. A minute. So this is 1 on all of this, so this will become 1 plus t squared all over 1 minus t squared. Very good. So this and this will go, so we'll be left with what? This will be equals to the integral of what? 2 dt all over what? All over 1 minus t squared. You get what I'm saying? But to integrate this, we cannot integrate it using substitution of sign. No, we cannot integrate it, because if this was plus, we could have recognized it as what? The integral of 1 all over 1 plus. If this was plus, we could have recognized it as what? The integral of arc tan t. You understand? If there was a square root here, this would have been 2 times the integral of dt all over square root of 1 minus t squared, which would have been arc sine of what? T. You understand? So this is a quadratic expression. What we are supposed to do here is what? You can find delta, but that will be a wastage of time, because this is a difference of 2 squared. So I'll directly recognize this, you understand, as a difference of 2 squared. So let me wipe this. So I'll copy back this. So 2 into the integral of dt all over 1 minus t squared will be equals to 2 integral of dt all over what? 1 minus t squared is the same as 1 square minus t squared, which is 1 minus t into what? 1 plus t. Is that okay? So let me wipe this. So this will be equals to integral of 2 times integral of dt over 1 minus t into 1 plus t. So to integrate this, what I will do is what? I'll first express this in partial fraction. So expressing 1 all over 1 minus t into 1 plus t in partial fraction. Okay, we know that 1 all over 1 minus t into 1 plus t in partial fraction, these are linear factors, will be identical to a all over 1 minus t plus b all over 1 plus t. Is that okay? So so it implies 1 all over 1 minus t into 1 plus t will be identical to what? The LCM here must be the same as what is here. 1 minus t into 1 plus t. This divided by this, I'll have a into 1 plus t plus this divided by this, I'll have b into 1 minus t. Now, for this to be identical to this, since the denominators are already identical, it means the top must be identical to this. So let me first draw a line here for me not to get confused. Let me draw the line. Okay, so it implies 1 will be identical to what? A into 1 plus t plus b into 1 minus t. There's no need of developing it and coming out with a system of equation, because if I want to find a, I can easily eliminate b by letting t to be what? 1. If I want to find b, I just need to eliminate a by letting t to be what? Minus 1. So when t is equals to, let's start by finding a. When t is equals to 1, we'll have 1 being equals to what? Here this will become 0. I will have 2a. So this implies a will be equals to what? A half. We have already our a. Now let's find our b. When to find b, we need to eliminate a. So I will let t to be equals to what? Minus 1 for this to become 0. When t equals to minus 1, what I will have is what? I'll have 1 being equals to 1. This becomes 0. And this, when t equals to minus 1 here, this becomes 2. Equals to 2b. So this implies b will be equals to what? B will be equals to a half. Yes, b will be equals to a half. Is that okay? So we know already our a and b, so we shall come and substitute it well here. Get what I'm saying? So this implies 1 on 1 minus t into 1 plus t must be identical to what? Must be identical to a was a half, so I'll have a half on what? 1 minus t plus b is a half on 1 plus t. So this will be identical to a half. 1, this 2 will go down. 1, this will give 1 on 2 into 1 minus t plus 1 on 2 into 1 plus t. Is that okay? So this 1 on 1 minus t into 1 plus t is identical to this. So we have already our partial fraction. Let's now take this and come and substitute it well in this integral we were finding. So we have found already this in partial fraction. Let's come and substitute it here. So we are going to have 2 integral of dt on 1 minus t into 1 plus t will be equals to what? Will be equals to 2 integral of what? I'll copy all of this. I'll replace it here. So this will give 1 on 2 into 1 minus t plus 1 on 2 into 1 plus t. You get what I'm saying? So times what? dt. Okay. These two, we cancel the 2 that's inside. So this will be equals to integral of what? 1 all over 1 minus t dt plus integral of what? 1 all over 1 plus t dt. Is that okay? Now, we know how to integrate this. These are linear functions. You get what I'm saying? It's like we are integrating 1 all over ax plus b dx. To integrate this, what you basically, this is simply equals to what? 1 all over ax plus b prime ln of what? The absolute value of ax plus b. Is that okay? So let me wipe this. So this will be equals to what? This will be equals to the integral of this will give 1 all over 1 minus t prime ln of what? The absolute value of 1 minus t. Is that okay? Plus 1 all over 1 plus t prime ln of the absolute value of 1 plus t plus our constant of integration. So this will be equals to what? When I differentiate this, I'll have minus 1. When I differentiate this, I have 1. So this will be equals to ln of what? The absolute value of 1 plus t minus what? Ln of the absolute value of 1 minus t plus our constant of integration. So this will give ln of the absolute value of what? 1 plus t all over what? 1 minus t, because this is ln of a minus what? Ln of b, which is ln of a on b, and since they are having the absolute value they choose, we have this plus our constant of integration. But remember, recall that if you can recall that our t was equals to what? Our t was equals to tan theta on 2. Our t was tan theta on what? On 2. So this implies the integral of what? 1 on cos theta d theta will be equals to what? Where we see t will replace by what? Tan theta on 2. So we will have ln of the absolute value of what? 1 plus tan theta on 2 all over what? 1 minus tan theta on 2 plus what? Constant of integration. Are you getting? So this is you could still be asked to leave your answer in some exercises. You will see that the integral of 1 on cos theta d theta will also be equals to this. Now we are already at this stage. We need to prove that this this 1 plus tan theta on 2 all over 1 minus tan theta on 2 is equals to what? We need to prove that it is equals to sec theta tan theta. Now, let me go to the next page. So we had that, finally, we had the integral of sec theta d theta was finally equals to the ln of the absolute value of 1 plus tan theta on 2 all over what? 1 minus tan theta on 2 plus our constant of integration. Let's prove that, let's find 1 plus, no, let's prove that 1 plus tan square theta on 2 is equals to 1 minus tan square. Hey, it's not tan square. What am I doing like that? Let me write this. Let's prove that 1 plus tan theta on 2 all over 1 minus tan theta on 2 over 1 minus tan theta on 2 is equals to what? Sec theta plus tan theta. Let's prove it. Okay. 1 plus tan theta on 2. This is a very, it's like we are doing a trigonometric proof. Trigonometric proof. Whenever you are given, wait a minute, please. So remember that whenever you are asked to do a trigonometric proof, always try to write everything in terms of sine and cos. That's the first thing you should always do. Always trying to write everything in terms of sine and cos. So this will be equals to what? 1 plus what? Tan theta on 2 is the same thing as sine theta on 2 all over what? Cos theta on 2. So all over, I'll do the same thing here. This will be 1 minus sine theta on 2 all over what? Cos theta on 2. Okay, very good. Now, I'll arrange things. This will be equals to, this will become cos theta on 2. When you simplify this, cos theta on 2 plus sine theta on 2 all over what? This cos theta on 2. Cos theta on 2. All over, I do the same thing here. I'll have cos theta on 2 minus sine theta on 2 all over what? Cos theta on 2. Very good. This will be equals to, it will become, this and this will go because this divided by this and this will interchange, and naturally this will go with this. I hope you understand what I'm saying. So this will be equals to cos theta on 2 plus sine theta on 2 all over what? All over cos theta on 2 minus sine theta on 2. Very good. So at this stage, what I'm going to do is that I'll multiply top and bottom by cos theta on 2 plus sine theta on 2. I'll multiply the top and bottom. I'll multiply the bottom, this bottom. I'll multiply this bottom by, in fact, what I will do is that I'll multiply this bottom by what? By its difference, difference of 2 square. That is, whenever you have, let's say, a square minus b square, it is the same as a minus b all over what? Times a plus b. So since under here I'm having cos theta on 2 minus sine theta on 2, I'll multiply top and bottom by what? Cos theta on 2 plus sine theta on 2. You understand? So this becomes, this will be equals to, this will be equals to cos theta on 2 plus sine theta on 2 into what? Cos theta on 2 plus sine theta on 2 all over. When I will multiply the bottom by this, let me first write it. Cos theta on 2 minus sine theta on 2 into what? Cos theta on 2 plus sine theta on 2. Is that okay? Okay, very good. Now I'll develop it. This will be equals to what? When I multiply this, it's like I'm multiplying a, I'm doing a plus b squared, which is a squared plus b squared plus 2ab. Is that okay? plus 2ab. So this will give cos square theta on 2 plus sine square theta on 2 plus what? Plus 2 sine theta on 2 cos what? Theta on 2. Very good. All over what? This is a difference of two squares. What is under here? So I'll have cos square theta on 2 minus what? Sine square theta on 2. Now, having reached at this level, you know that if you can remind yourself, cos square n theta plus sine square n theta is equals to what? 1. Is that okay? Also, 2 also sine n theta is equals to what? Is equals to 2 sine n theta on 2 all over times what? Cos n theta on 2. Is that okay? And finally, cos square n theta on 2 minus sine square n theta on 2 is equals to what? Cos what? Cos n theta. Is that okay? So we shall recognize it here. So this will be equals to what? You have cos square theta on 2 plus sine square theta on 2. This is 1. So I will have here 1 plus what? 1 plus, this is 2 sine theta on 2 cos theta on 2. This formula says that 2 sine n theta on 2 cos n theta on 2 is equals to what? Sine n theta. So this is simply what? Sine what? Sine, this is simply sine theta. Sine theta is equals to what? 2 sine theta on 2 cos what? Theta on 2. Let me first recall this. It's very important to show that in the exercise. But recall that cos square n theta plus sine square n theta is equals to what? 1. Sine n theta is equals to what? 2 sine n theta on 2 cos n theta on 2 and cos n theta cos n theta is equals to 2 is equals to cos square n theta on 2 minus what? Sine square n theta on 2. So when you have already written this, the examiner will understand what you will be doing up here. So it implies this. So it implies cos square n theta on 2 plus sine square theta on 2 plus 2 cos theta on 2 sine, wait, let me write it, I made an error here, plus 2 sine, this is sine, don't forget, this is sine theta on 2 cos theta on 2 all over cos square theta on 2 minus sine square theta on 2 will be equals to what? This will give 1, so I'll have 1 plus this will give sine theta plus this, all of this is sine theta plus sine theta all over what? The whole of this will give what? Will give what? Cos theta. That's it now, because this is what the formula says. Because these are the half angles here. So all of this will give what? Cos theta. So this implies this is the proof we wanted to do. So this implies 1 plus tan theta on 2 all over 1 plus all over 1 minus all over 1 minus tan theta on 2 will be equals to 1 plus sine theta all over what? Cos theta. But look at something. If you divide all of this, you know that A plus B on C is equals to what? A on C plus B on C. So I will apply it here. So this implies, so this will be equals to 1 on cos theta plus sine theta on what? Cos theta. Implying 1 plus tan theta on 2 all over 1 minus tan theta on 2 is equals to what? This is what? 1 on cos is sec. Is that okay? So this will give sec theta plus sine theta on cos theta is what? Tan theta. You see that we have proven that this is equals to sec theta plus tan theta. So this implies the integral of sec theta d theta, which was equals to the ln of the absolute value of 1 minus tan theta on 2 all over 1 plus tan theta. Oh, this is plus and below it is minus all over 1 minus tan theta on 2 plus a constant k is equals to what? Is equals to, since we proved that this is equals to sec theta plus tan theta, we just replace it inside here. So this will be ln of what? Sec theta plus of the absolute value of sec theta plus tan theta plus our constant k. So we have proven that this is equals to this. Now, for the second part, we basically need to prove what? For the second part, we basically need to prove that this sec theta plus tan theta is equals to what? This. You get what I'm saying? Okay. For the second part, let's prove that ln of sec theta plus tan theta, ln of sec theta plus tan theta is equals to what? Ln of the absolute value of tan x on 2 plus pi on 4. Okay, to prove this, what I will do is this. Look at this in a very keen way. Look at this in a very, very keen way. So be very keen at what I'll do. So let's prove this. To prove that, we simply need to show that ln of what? We simply need to show that sec theta plus tan theta must be equals to what? Tan of x on 2 plus pi on 4. Okay, I'll prove. How am I going? I'll prove this starting from here. You are free whenever you are asked to prove a trigonometric identity. You are free to start from any side. If you are capable of proving from this, going this side, then okay. If you are capable of proving starting from here to here, then okay. But me, I'll start from here. I'll prove from the right side going to the left. You understand? Because it will be very complicated for me to bring in a pi on 4 here. You understand? So that's why I'm leaving. I'll prefer to prove from here to here. You get what I'm saying? Okay. tan x on 2 plus pi on 4 is equals to what? Let me recall a simple formula. Tan, let me give you a simple formula. Tan of A plus or minus B is equals to tan of A plus or minus the tan of B all over. Now the sign will change here. I will have 1, since it is plus on top, it will change and become what? Minus plus tan A tan B. This is what this simply means. If I'm calculating, if I'm given with a plus, that is tan of A plus B, it will simply be equals to what? I'm supposed to have, since there is plus, I'm supposed to have what? Tan A plus tan B all over what? Under, I will have what? The opposite of this sign, 1 minus tan A tan B. If it is minus, tan of A minus B will be equals to tan A minus tan B. Now under, I will have the opposite, 1 plus tan A tan B. Is that okay? So I will just apply these formulas. So let me wipe this first of all. It's a bit big. So tan of x on 2 plus pi on 4 will be equals to what? Will be equals to, there is a plus, so I will use this formula. So tan x on 2 plus what? Tan pi on 4 all over what? 1 minus what? 1 minus this. 1 minus tan x on 2 times what? Times tan pi on 4. Now, tan of pi on 4 is sine pi on 4 all over what? Cos pi on 4. And sine of pi on 4 is simply sine of 45 degrees, which is root 2 on 2. Cos of pi on 4 is cos of 45 degrees, which is root 2 on 2. So this will give what? 1. So this will be equals to tan x on 2 plus what? Tan x on 2 plus what? Plus 1 all over what? 1 minus, this gives us 1, tan x on 2. Is that okay? Oh, it's inside tan theta. We're supposed to have theta here. This is theta. Yes, this theta. This is theta. This is theta. This is theta on 2. This is theta on 2. So this implies tan theta on 2 plus pi on 4 will be equals to what? 1 plus tan what? Theta on 2 all over what? 1 minus tan what? Theta on 2. But if you can recall very well, we have already proved that this, remember, if we go back to the previous page, we have proven already in the integral that we were finding, we have proven already that this is equals to what? Sec theta plus tan theta. You get what I'm saying? We have already proven that it is equal to this. We have already proven that it's equal to this. So there is no need of writing all those steps again. So I would just say that but from what has been done previously, when finding the integral of 1 on cos theta d theta, we had 1 plus tan theta on 2 all over 1 minus what? Tan theta on 2. We showed that it was equals to what? Sec theta plus what? Tan theta. So we can basically conclude, therefore, the integral of sec theta d theta must be equals to what? Which was equals to what? Ln of 1 plus tan theta on 2 all over 1 plus all over 1 minus, this is minus tan theta on 2 plus a constant of integration will be equals to what? Ln of what? Absolute value of sec theta plus tan theta, which is also plus a constant of integration, plus the constant of integration, which will also be equals to what? What we have seen here. You get what I'm saying? So here you are supposed to conclude first of all that this implies tan of x on 2 plus pi on 4 is equals to what? Sec theta plus tan theta. So this integral will be equals to, so this integral is equals to this plus the constant, which is still equals to what? Ln of the absolute value of what? Tan x on 2 plus pi on 4 plus our constant of integration. So that's basically how you do it. So you basically see that the integral of sec theta, it's either this. So in some exercises, you know already how to prove this, because the answer you always have at the end will be something of it, will be this. Now you will have to prove that this is equals to what? Sec theta plus tan theta. If you are also asked to prove that this ln of sec theta plus tan theta plus a constant k is equals to ln of the absolute value of tan x on 2 plus pi on 4 plus k, what you basically have to prove is that this, what is inside here, must be equals to what? This. You get what I'm saying? And I gave you some formulas there that can be very helpful. So that was all for this question. We were not capable of doing we were not capable of doing in this video the integral of cosec theta. So as assignment, I want you to do the integral. I want you to do the integral because the next question was to do, I think it's question 6, was to prove that, I want you to prove that the integral of cosec theta d theta is equals to what? Ln of the absolute value of cosec theta minus cot theta plus a constant of integration, which will be equals to, again, at ln of the absolute value of tan x on 2, tan theta on 2, pardon, tan theta on 2 plus a constant k. So try to do it. This is your assignment. I will not do it. It's very simple. Just use the same logic as what we did previously. So here, this, and remember that cosec theta is the same as what? 1 on sine theta. So basically, you know that your substitution here will be what? T, because this is in the form what? 1 all over a plus b sine nx plus what? C cos what? Nx. Is that okay? So your substitution will be what? T. You will let your t to be equals to what? Tan of this divided by 2. The angle here divided by 2. Nx divided by 2. So the substitution here will be what? T will be equals to tan of what? Nx is simply theta. Theta divided by 2. You get what I'm saying? So try to do this proof. I want you to do this proof. You understand? Just use the same logic as what we've used in the integral of sec theta. You get what I'm saying? I'll also give you the hint on this other one. I want you to do also this exercise. Where is it even? Yes, you will do this once. I'll not do them because they will take me a lot of time. You'll do this, and what again? You will do this last one. Remember, these are integrals of the form 1. a on what? These are integral of the form dx on what? A plus b sine nx plus what? C cos nx. So here, basically the substitution here, for this one, the substitution will be t equals to what? Tan of what? Nx divided by 2. Our nx here is 5 theta. So 5 theta divided by what? By 2. You get what I'm saying? So just use the same procedure as all what we did. Here, your substitution, you have t being equals to what? Tan of what? Nx divided by 2. So x on 2. Is that okay? Same thing, your substitution here will be what? T being equals to what? Tan nx divided by 2. Nx divided by 2. You get what I'm saying? So try to do these integrals. They are very simple. Same thing here. The substitution will be what? T being equals to what? Tan nx divided by 2, because it is of this one. So I'll have 3 theta divided by 2. Is that okay? So try to do all of these exercises in the next video. So in the next video, I'm going to do yes, in the next video I'm going to do this. I'm going to do the remaining exercise. So I'll do this. We've done this already. So you have to do all of this. Do all of them. They are very simple. They are very simple. You know already which substitutions you have to do, and you know how to proceed. So in what again? Wait, let me see. Um, um, so I'll do this in the next video. I'll also do yes, in another video I'll do this and this, you get, for you to know which substitution you are to have, you are to work with. And in the last video I'll do this and this. Okay, so see you in the next video. Try to do the exercises. They are very simple, and take care.